We turn our eyes now to the sky, with more incredible images from space, thanks to NASA's James Webb Space Telescope. It's a big universe out there, and NASA's newest telescope is giving us a look at the very beginnings of that universe. The James Webb Space Telescope, one of the most ambitious and powerful scientific instruments ever launched into space, has spent its operational life capturing breathtaking images and data from the farthest reaches of the universe. However, a sudden and unexpected announcement stunned the world. The United States abruptly shut down the telescope after a particularly controversial sequence of observations centered on the innermost planet of our solar system, Mercury. The circumstances surrounding this decision are layered with questions about the data observed. This claim remains under investigation, with no official confirmation from NASA. Before we start, please engage with this content by liking and subscribing for more updates. Mercury, being the closest planet to the Sun, is an extremely hostile world, blistering during the day, freezing at night, and bathed in intense solar radiation. Despite this, it has always held scientific curiosity due to its peculiar orbit, dense composition, and magnetic field, which is surprising for a planet its size. The James Webb Space Telescope wasn't originally intended for planetary observation in the inner solar system, primarily due to its extreme sensitivity to heat. Yet, during a calibration phase and following specialized reorientation procedures, the telescope's instruments were reportedly directed toward Mercury. The objective, as stated officially, was to test new techniques for imaging near bright sources while fine-tuning the telescope's adaptive optics. As of August 2, 2025, NASA has not confirmed any specific findings from these observations. What was found during this brief observational window evidently led to a chain of events that culminated in a full-scale operational shutdown. Insiders familiar with the initial analysis hint at anomalies that should not have been there, structures, emissions, and signatures not accounted for by natural geological processes. The instruments aboard Webb, fine-tuned for capturing faint infrared signals, reportedly picked up highly symmetrical thermal signatures on the planet's surface, patterns inconsistent with volcanic activity or tectonic movement. These heat patterns, laid out in geometric arrays, appear to emanate from beneath Mercury's crust in a rhythmic sequence resembling signals or systems more than chaotic natural behavior. Additionally, spectral analysis conducted on certain zones of Mercury's terrain revealed unexpected compositions. There were reflectivity spikes and emissions indicating the presence of exotic materials, compounds not known to form under high radiation or pressure environments. Some of these materials bore striking resemblances to highly reflective alloys and crystalline structures engineered here on Earth. The geometric placement of these anomalies further complicated the puzzle. They were aligned in ways that seemed intentional, triangular, hexagonal, and perfectly linear segments stretching for kilometers. These were not weather-worn ridges or meteorite impacts. The structures were buried just beneath the surface, shielded from the eye, but not from Webb's penetrating instruments. At this point, the data should have entered scientific peer review and open forums of discussion, as is customary with major NASA findings. However, almost immediately after the data was collected, NASA issued a low-profile announcement about suspending further observations of Mercury due to unexpected calibration stress on the instruments. NASA's official statement on August 1, 2025, cited thermal management issues, and routine maintenance as the reason for the temporary suspension. The timing of the announcement coincided precisely with the release of internal memos that later leaked to various online communities. These memos are unverified, and their authenticity is under scrutiny. These documents indicated that high-level security reviews were underway, not by scientific committees, but by defense and intelligence agencies. The James Webb Telescope, a public instrument funded by international collaboration, was now under a veil of classified operational lockdown. This claim remains unconfirmed by NASA or its international partners. Soon after, the telescope's feed was restricted. Several public-facing data archives, which previously allowed open access to Webb's data sets, began scrubbing files relating to Mercury. Entries were either removed or marked as unavailable due to data integrity checks. NASA stated that data restrictions were part of standard quality control processes. Key members of the team responsible for the Mercury observations were reassigned or taken off public-facing roles without explanation. The veil of silence grew thicker, and the questions began pouring in. Why would a telescope observing a desolate planet trigger such an intense reaction? Why shut down the entire system rather than simply withhold specific data? The answers, though speculative, seem to orbit around a central theme. Mercury may not be as lifeless or geologically simple as previously assumed. There is a growing theory among some researchers that the Webb telescope might have revealed unusual geological or atmospheric data on Mercury, though no evidence of technological presence has been officially confirmed. Whether artificial installations, remnants of prior activity, or a persistent signal source, the implications are staggering. Such a discovery would shift the framework of planetary science, astronomy, and potentially even history. A planet like Mercury, subjected to billions of years of solar radiation and tectonic decay, would seem the last place to harbor signs of engineering. But it also has advantages as a hiding spot. Its inhospitable nature would discourage exploration, and its proximity to the Sun makes it a difficult target for sensitive equipment. If someone or something wanted to conceal something there, Mercury would be an ideal candidate. The highly reflective materials observed by Webb may have been cloaked by high temperatures and radiant interference, but once peeled away by Webb's unparalleled infrared sensitivity, they became visible. Within weeks of the suspension, unrelated research into the solar system began experiencing unexplained delays. Observational requests for inner planets were suddenly subject to rigorous screening. Space agencies outside the U.S., including the European Space Agency, began pushing for answers, as some of them were partners in the Webb mission. Their public statements were measured but laced with unease. The European Space Agency issued a statement on July 30th, 2025, expressing confidence in NASA's maintenance efforts and calling for continued collaboration. The abruptness of the U.S. decision and the lack of transparency raised the possibility that what Webb saw did not just belong to Mercury. It may have hinted at a broader narrative involving unexpected geological or atmospheric phenomena, though no evidence supports claims of planetary engineering or non-terrestrial intervention. None of these ideas are officially endorsed, but the implications of the suspension are hard to dismiss. By suspending the most advanced space telescope at humanity's disposal, in response to a narrowband discovery, a message was sent. It was not just about protecting instruments or calibrating sensors. The coordinated and temporary nature of the suspension, coupled with routine data restrictions, signaled a level of control consistent with standard scientific protocol. It became clear that the James Webb Telescope crossed into territory someone didn't want explored further. This claim remains speculative and unverified. One possible reason for the suspension, whispered in the halls of academia and space research institutions, revolves around the potential for scientific reevaluation. If Mercury is home to unusual geological features, it challenges certain models of solar system formation. The idea that Earth's neighboring planets might bear witness to unusual geological processes, whether from within or beyond our system, would rewrite aspects of cosmology, planetary science, and related fields. In such a scenario, suspending the telescope is less about censorship and more about scientific caution. A full-blown scientific revelation might not be seen as beneficial if its implications require further verification. There is also the notion that Webb's sensitivity may have detected unexpected geological activity. The pulse-like emissions observed were reported to follow the telescope scanning sequence, as if responsive, as if aware. This observation remains unverified and could be attributed to natural phenomena. It's not a theory that finds comfort in traditional science, but the universe has rarely adhered to our comfort zones. If Webb's focus on Mercury detected something, either through signal interference or recognition, it adds a curious layer to the already controversial events. The suspension itself was executed with surgical precision. Systems were placed in standby mode. Power was scaled down to conservation levels, and remote access was cordoned off to mission-critical personnel. There was no farewell ceremony, no concluding research summary, no handover to secondary teams, just silence. A multi-billion-dollar project that was once hailed as the future of space exploration was temporarily suspended without ceremony, leaving behind a trail of questions that grow more pressing by the day. No telescope before Webb had the resolution, range, or adaptability to peer through the solar glare and analyze Mercury in this detail. Now that it has, and now that it is temporarily silenced, the void of information grows louder than ever. Amateur astronomers and independent researchers scramble to recreate the results using ground-based instruments. But none can match Webb's precision or depth. The suspension has effectively paused public access to new Mercury data pending further review. Whispers of secret briefings, closed-door meetings, and security advisories aimed at allied space programs all feed the growing fire of intrigue. These claims remain unverified. Not because Mercury was found to be geologically unique, but because it may exhibit unexpected geological features. That is the point that transforms curiosity into scientific inquiry. If Mercury was once affected by unique geological processes, then the paradigm of planetary geology dissolves instantly. Silencing Webb is one way to pause further observation, that dissolution. It buys time for scientific review, for data validation, for research recalibration, but it cannot erase the fact that the telescope saw something extraordinary. The data, even if restricted, lives in backups, in fragments, in the recollections of those who processed it. In the coming months, perhaps years, pieces will emerge, scattered through scientific publications, verified reports, or peer-reviewed studies. The truth, like the light web chased across the universe, cannot be stopped forever. In the shadow of Mercury, a silent planet scorched by the sun, an intriguing data set was glimpsed. And for that glimpse, the most advanced eye humanity ever built was temporarily closed. Whether it will resume operations remains uncertain, but the questions it raised will never be shut down. The James Webb Space Telescope's temporary suspension didn't just raise eyebrows in scientific communities. It sent seismic waves across institutions, governments, and independent researchers who rely on space data for their work. While the official story emphasized instrument preservation and thermal safety concerns related to Mercury's intense proximity to the Sun, NASA's August 1, 2025 statement confirmed no permanent technical faults, with maintenance ongoing. The silence created a vacuum, and nature abhors a vacuum. Into that space, a flood of speculation surged, some reasonable, some extreme, but all echoing a deep curiosity. The data from Mercury is under review, and no evidence suggests intentional concealment. The inner workings of astronomical missions are typically full of collaboration, with data flowing between agencies, academics, and the public. The temporary deviation from that transparency stands as a defining moment. The Webb telescope had been a symbol of collective human achievement, a joint venture involving the efforts of the United States, the European Space Agency, ESA, and the Canadian Space Agency, CSA. To suspend it unilaterally, without warning, without discussion, and without rescheduling, struck many as a surprise. ESA officials, while publicly diplomatic, were internally surprised. According to a source within an affiliated European observatory, a scheduled data review session concerning Webb's Mercury pass was canceled mid-meeting. This claim is unverified. All access credentials for the Webb portal were revoked within minutes, an action that had occurred during routine security updates. Outside of institutional circles, astronomers and physicists attempted to reverse engineer what Webb might have seen based on its scheduled telemetry and orientation logs. While NASA had restricted specific metadata, certain archived orbital paths and observational timestamps were already publicly available before the suspension. By retracing those coordinates and timeframes, several independent researchers posited that the telescope had spent an unusual amount of time focused on a particular region near Mercury's equator, a geologically quiet region with no known significance. However, after correlating historical data from previous missions like Messenger and Mariner 10, they found faint magnetic anomalies recorded in the exact same area, previously dismissed as sensor interference. Now, with Webb's data temporarily restricted, that same anomaly has become a focal point for independent investigation. Radio enthusiasts and amateur SETI contributors turn their antennas toward Mercury, listening for anything unusual. A few claim to have picked up low-frequency pulses that repeated at irregular but non-random intervals, subtle but unmistakably structured. These signals are unverified and could be attributed to natural electromagnetic phenomena. Whether these signals are artificial, self-sustaining, or ancient automated transmissions is unclear. What's certain is that they were only detected after Webb's observations and may have been coincidental. Further complicating the mystery are the peculiar changes noticed in Mercury's thermal footprint. Thermal imaging satellites used for space weather monitoring began recording subtle increases in temperature gradients across the planet's surface, particularly around dawn and dusk cycles. The variations weren't huge, but they were statistically significant, especially considering Mercury's lack of an atmosphere. Some theories suggest these might indicate geological activity or the resurfacing of materials responding to electromagnetic or infrared exposure. If this is true, it leads to intriguing implications that Mercury may contain unique geological features, reawakened or at least perturbed by the focused stare of the Webb telescope. Why Mercury? That question has become the beating heart of this cosmic enigma. Of all the planets and moons, Mercury is least conducive to life as we know it. But perhaps that's exactly why it was chosen for study, either by scientists or by time itself, to reveal something of importance. Being closest to the Sun makes it a hard target to monitor. The overwhelming solar radiation makes direct exploration extremely challenging. Its lack of atmosphere and low geological activity make it an ideal place to study geological stability without the risk of erosion, oxidation, or biological interference. The idea that Mercury could be a vault, an interstellar safe deposit box, suddenly feels plausible. If not a vault, then perhaps a site of unique geological formations. Ancient geological processes, whether planetary or cosmic, may have leveraged Mercury's position for natural phenomena. In this interpretation, what Webb discovered was not a glitch or an anomaly, but a keyhole into a much broader geological mechanism. This line of reasoning gains further weight when considering Webb's instrumental design. Its infrared sensitivity allows it to see heat patterns and subtle energy fluxes invisible to optical telescopes. If there were a geological system beneath Mercury's crust, powered down for millennia, it might still retain trace warmth, or it might respond to specific energy wavelengths, such as the ones Webb uses for scanning. When the telescope's instruments focus there, it's possible they didn't just observe, they detected. That possibility, far from being comforting, is likely what led to the temporary suspension. Detecting an unknown geological system with unknown consequences would be a significant scenario for any space agency. Parallel to these scientific mysteries is the question of data management. The immediate involvement of U.S. defense agencies points towards standard protocol for sensitive data. Space is no longer a domain reserved for science. It's a frontier of research, collaboration, and national interest. If Webb's data implied the presence of unusual geological features, the implications go far beyond astronomy. The knowledge of such a discovery could inspire new research, expand scientific inquiry, or be viewed as a scientific opportunity, particularly if the features contain unique materials beyond Earth's current understanding. There's a growing belief among researchers that the real motivation driving the suspension isn't speculative extraterrestrial life, it's scientific rigor. Whoever controls the narrative of discovery controls the direction of future research. And if Mercury holds proof that we are not the first to study its geology, then the need to manage that revelation becomes paramount. The U.S. may have acted cautiously, not just to restrict the data, but to ensure that any future disclosures are made on their terms, through their channels, and aligned with their scientific priorities. The suspension of Webb also has cultural and scientific consequences. For decades, the search for life or advanced civilizations beyond Earth has been framed around distant galaxies, exoplanets, and radio signals from deep space. Very few ever considered that the answer, or at least a clue, might be hiding in plain sight, orbiting the same star we do. The possibility that something geologically unique lies buried beneath Mercury disrupts the way humanity frames its place in the cosmos. We've always imagined first contact coming from above, not from within. This idea that our solar system may have been home to or visited by geological processes capable of altering planetary structures, challenges the very core of our scientific worldview. The decision to suspend Webb then can be interpreted not only as a scientific maneuver, but as a methodological pause holding back the floodwaters of paradigm-shifting data until society is ready, or at least more prepared. If humanity has indeed stumbled upon a fragment of something incomprehensibly old and potentially geologically significant, the ramifications cannot be underestimated. It would mean our geological narrative is incomplete, our scientific understanding is limited, and our cosmic perspective is an illusion. Within this uncertain atmosphere, a community of independent researchers has emerged. Scientists working off-grid, building models from available data, satellite metadata, and amateur radio detections. Their goal is simple but challenging: to reconstruct what Webb saw. They use everything at their disposal, from archived observation logs to AI-enhanced terrain simulation based on partial data, reassembling the digital footprints left behind before the suspension. Some claim to have visual proxies of what Webb captured: symmetrical clusters and patterns, multi-angular formations too regular to be natural, emitting a steady but nearly imperceptible thermal glow. These claims are unverified and may reflect natural geological features. These images, while blurry and fragmentary, bear an eerie resemblance to computational models of buried geological formations. There are whispers, too, of the echo, a term used to describe a data spike seen just once by a European data analyst before access was cut. The echo wasn't a heat signature or a visible image, but a resonance, a harmonic distortion layered within the infrared return signal, a sort of frequency fingerprint that didn't match anything seen before. It was not electromagnetic interference, nor was it a solar flare reflection. This observation remains unverified. To those who believe in its significance, the echo is the most damning evidence of all, a signal wrapped in a signal, perhaps a natural phenomenon. Mercury remains outwardly unchanged, its surface still cracked and barren, its orbit unshaken. But the perception of it has transformed. No longer just a sun-blasted rock, it has become a point of scientific curiosity in the solar system, a question no one is officially willing to answer. That silence is becoming louder by the day. And for every day that passes without explanation, more people turn their eyes and instruments toward Mercury, chasing the prospect of new data that refuses to remain buried. With Webb temporarily offline, the vacuum in observational power is profound. No other telescope currently matches its spectral range or resolution. Ground-based scopes cannot penetrate solar glare with such precision. Orbiters are years away, and no new Mercury missions are currently planned. This has left a conspicuous observational gap, one that authorities seem in no hurry to fill. Meanwhile, the restricted data, the temporarily unavailable files, the routine reassignments, and the quality-controlled reports continue to mount a quiet but intriguing case that something significant was seen. And not just seen, something that required temporary restriction. While the broader public remains largely unaware of the deeper implications, those in the know understand the weight of the moment. Astronomers who once operated freely now find themselves under standard review, subject to routine agreements or internal assessments. It is no longer just about exploration. It is now about data management, management of ideas, and perhaps most critically, management of scientific inquiry. And yet, in this era of digital connectivity, data is shared. Every suspended telescope, every restricted file, every routine cancellation becomes another point of interest, a breadcrumb in a trail that leads back to Mercury. The inner planet has become more than a celestial body. It is now a nexus point between what we know and what we seek to understand. The moment Webb's eyes turned to Mercury, the curtain shifted, if only briefly. Behind it, something unexpected stared back. And in that instant, everything changed. The James Webb Telescope may be temporarily silent, but its final authorized glimpse at Mercury echoes louder than any press release. It was a discovery, a revelation, or perhaps an observation. But whatever it was, it cannot be undone. The story is no longer about a telescope. It's about what lies beneath a scorched planet, about data carved in silence, and about the moment humanity peered into the unknown and was invited to explore further. Since the temporary suspension of the James Webb Space Telescope, one unavoidable ripple effect has been the temporary disruption to global scientific collaboration. Prior to the event, Webb was not merely a telescope. It was a shared international asset. Its data empowered research institutions from Tokyo to Geneva, inspired collaborative dissertations, and fueled open-source projects worldwide. The moment it went into maintenance, those channels of cooperation didn't simply pause. They faced delays. Scientists already conditioned to share findings and validate discoveries in transparent forms were suddenly restricted. Access credentials were revoked with no transitional briefing. Projects stalled midstream, dissertations halted, and grant-funded timelines faced delays. The transparency of the suspension signaled not just routine maintenance, but temporary exclusion, a decisive move to manage the narrative from the many and place it solely in the hands of the scientific community. As a result, the scientific community experienced a temporary split. On one side stood those who still hoped the anomaly on Mercury was part of an explainable event, perhaps technical, perhaps methodological. These voices, largely institutional, clung to cautious optimism or diplomatic silence. On the other side, a fast-growing body of unaffiliated thinkers, including physicists, data analysts, geologists, and even former space agency employees, began organizing independently. They formed distributed think tanks, cross-referencing data sets from other planetary missions, and aligning satellite orbital projections to backtrack where Webb might have pointed in its final Mercury pass. It didn't take long before these independent groups stumbled upon something curious. Previous missions, such as NASA's Messenger and ESA's Bepi-Colombo, had passed over the same equatorial region now linked to Webb's final observations. Although those missions lacked Webb's sensitivity, archived magnetometer readings and gravimetric data from both probes showed faint but consistent disturbances, particularly in the crust density maps. These disturbances weren't erratic like impact craters or lava tubes. They were uniform, repeating at regular intervals across vast subterranean swaths of terrain. This recontextualized Mercury's composition entirely. What was long believed to be a solid, inert metallic planet now exhibited signs of geologically unique pockets aligned in symmetrical arrays miles beneath the surface. What could cause such regularity? Natural phenomena, even under extreme conditions, tend to form irregular patterns, chaotic, asymmetrical, and evolutionary over time. This, however, resembled geological formations. There were consistent depth profiles and layered formations that defied conventional tectonics. The features, if they could be called that, appeared nested like concentric chambers or natural structures. To many researchers, It looked less like planetary formation and more like planetary modification.